Sweet.
Take it away, Kevin and Eric. Woo. All right. So sorry about the setup because we were supposed to be set up a little bit earlier, but we had a client in here, so that's probably just as important, if not more important than this. So apologies for this, and also for changing the time of it yesterday because we just found out about it. But thanks for sticking around. So I think all of you know me, but my name's Kevin Mack, and this is Eric Katz. And for the recording, we are both consultants at Cardinal Solutions, and we're talking about Git. And today, kind of our takeaways that we want you to have is a base understanding of Git, so the definitions of it, as well as the processes that are related to it, so those keywords that you hear when people are talking about Git. And if you end up on a project that uses Git, you'll kind of hopefully be able to jump in there and not have too many questions. And our outline to kind of go through everything that we're talking about, we'll first define what Git is, and we'll do it through some highlighted points about what Git is. We'll also talk about some of the benefits of Git, and then we'll dive into the definitions and those pieces about Git. And then we'll get into installing Git on your machine for both Windows and Mac. And then we'll talk about those variations in project setup, so the common patterns that happens in a project that is actually a Git project. And then we'll get into some best practices and approaches working with Git. And with that, we'll talk about the Git flow process, which is both of Eric and my favorites. And then we'll do this live demo that will kind of highlight everything that we've talked about. So at the end, if there's time for questions, we can do that. Or if you want to stick around and ask for questions, just due to time, if you have questions, unless it's something like I completely messed up and I see everyone's hands go up, we're going to wait to do questions until the end. So just being conscious of people's time. All right. So if you do a Google search for Git, the first thing that comes up is this weird word, which is a British word, that is an unpleasant person. That is not what Git is, so don't even think that. Another thing that really irks me and is not what Git is it's not GitHub. And so many people say that. It's a lot of times when I'm in interviews and I'm asking people, like, what about Git? They're like, oh, do you mean GitHub? I'm like, no. Git is the repository hosting service. So there's multiple ones out there. There's Bitbucket, and we'll be using that in our demo. There's GitLab, which we use here at Cardinal Solutions. TFS has actually a Git instance that you can be using. So there's multiple ones out there. So GitHub is just a repository service. It is not actually Git, if that makes sense. So then what Git really is, it is a version control system for software development. Again, it's like, you can compare it to things like CVS, SVN, and also TFS. So it's just another way to control the code that you're working on and to collaborate with teams. Eric's going to talk about some of the other pieces that define what Git is.
Yeah, so unlike other version control systems, Git is it's kind of like a snapshots-based repository system. And what I mean by that is whenever you have your code base and you're making changes to it, and you commit those changes to your repository, it's going to take a snapshot of your entire project state and not just record differences over time. And
sorry about that.
That's okay. Yep. And basically, the other key point about Git is that it's a distributed repository system. So when you pull down a copy of your code base, nearly everything you do is going to be local. The only time you're going to ever need the internet connection using a Git repository is when you reach out and connect to a repository hosting service like GitLab or Bitbucket or GitHub. And because of the way it works with its snapshot system, I just wanted to reiterate that it's basically an additive process. There's nothing you can do, almost nothing you can do to your repository that will eliminate some sort of historical information about your code. So it always adds and records data as snapshots. A few things to know about the state of your project files using Git is that there are 3 main states. There's committed, staged, and modified. We'll talk about that a little bit more later, I guess. So let's talk about why you should be using version control and Git in general. So the first point is that Git helps create this collaborative atmosphere for you and your dev team. Along with other tools that we use outside of our version control, like Trello or Kanban boards, things like that. Git kind of enables this collaboration between you and your team. It lets you take a copy of your code base, work locally without any sort of repercussions to possibly affecting your teammates, and lets you experiment with your feature that you're working on. So in the end, if things don't work out, you can always kind of abandon it or salvage pieces of it and bring that back into your project. And yep, when you work on your project in Git, the cool part about it is even if you're pulling down a code base and using it as like a starter pack, in the later demo, we'll be talking about the pattern library starter kit that Lauren Dorman and Kevin Mack worked on earlier. And the nice part about this is that it's a good example of a project that was based off of another project that kind of went on and became something that we use day to day at Cardinal. But then any sort of features that we want to pull back into the original pattern lab code base, we can always do that later. So, yep, and it's better than TFS. Yeah, so.
Yeah, there's a lot more benefits than that. These are just the first 4 that came to our mind, especially this last one.
Where's your source?
It was a quote from me.
Yeah.
So Eric's going to talk about installing Git.
Yeah, so installing Git, there seems to be this misconception that it's this arduous, complicated process, but really it's not complicated at all. You can just Google install Git, go to the Git official page, download, run the installer, and then maybe there's a few additional steps if you're on Windows, if you have to add it to your path, or set up an SSH key if you're connecting to a remote repository service. But essentially, to just work with Git as a version control system, all you need to do is go download the installer, run the installer, and use Git. You know, like we mentioned earlier, Git is completely local, distributed. The only time you ever need the internet or an SSH key even is to reach out to an external repository source. So an SSH key, I mentioned that. If you're not familiar, an SSH key is kind of like your username and password. It's basically an authentication system that's based off of a private public pair key that you generate on your computer. You install a public key at your source repository system, and then whenever you make a code commit and share it with that external repository, you're going to authenticate using your key pair. So that's what an SSH key is. And to prove how awesome it is to install Git, this is just a quick video of the actual process. You'll go into your bar, type install Git, go to the git-scm.com domain, the official Git documentation site, and then scroll through your choices for installs, pick whatever OS makes sense for you, click download. It'll take you to like SourceForge or some other external download hosting site. Give it a few seconds. Don't click on any of these weird ads that tell you to download stuff. And once the installer is done, that's it. You run the installer. And then...
Yeah, the thing that always throws off me and everyone when they're talking about installing Git is it takes you to this weird page, but just literally be patient because there's this small little like countdown here at the top that says like 4 seconds. I mean, it is open source, it is free. I think that's how they make their money. I don't know who actually clicks on it, but a few times I've by accidentally clicked on one of those links. So just be cautious. That's one of those cautionary tales.
Yeah, don't install any antiviruses this way. So you run that installer that downloads, and then to test it, you'll just open up your terminal or your command line. In Mac, it's terminal, and Windows, it might be PowerShell or PuTTY. And you just type in Git. If you get feedback results of a bunch of commands, you probably did it right. So next, let's talk about how we can connect to our remote repository service like Bitbucket. You'll just log in with your account or create an account if you haven't created one yet. Go to your account, My Account section, manage your account, same thing. Click on your SSH keys, and then add your key. So it'll give you a spot for a label and then a place to paste your key. The label should just be an identifier for yourself to tell you what computer that SSH key belongs to or what that SSH key is installed on. And then you'll paste your key in. If you need to know how to create an SSH key, the process is pretty simple. We'll have a video about going through, and all you do is just search GitHub SSH keys. They have really good documentation on creating your own SSH keys, generating them.
And the reason why it's GitHub on this, because they have literally one of the best documentations on it. It's not, if you did a Git SSH key, you'd probably get a bunch of different results. But for the GitHub one is the one that I always reference.
Yeah, and so you'll go through, you'll write a command into your command line. It'll start asking you prompts about whether you want to add a passphrase or things like that. Hit enter, it'll store it as a default location. If you want it, you can name it something else, but then that's about it. You'll just go through, copy and paste the contents of your SSH key.pub file, and that's about it.
Yeah.
Pretty easy.
Yeah, the hardest part is just doing a search for Google and going through the prompts. And then after that, you have Git installed, and then setting up an SSH key. And the SSH key, if you're using this, is really easy to use. So getting into project setup, and again, I'm just going to be talking about some of the basic flows and understanding of the different projects that you may be working on. So the first one is your first project or initializing it. So after you have Git installed, there's this basic setup of number one, and that is, I'm going to go through each one of these, but 4, 5, and 6 are going to be common for every single pattern that we see. So just be on the lookout for that. You're going to hear me say add, commit, push a lot. And these first 3 are really on the first time that you set up a project. So talking about a init. Init is when you initialize the Git instance for the project that you're working on. So you have a directory. It could be a pre-existing project. You may already have like SVN or even TFS for your project. You can still initialize Git. So all you have to do is go to a directory and initialize Git. And now because of that, it has become a Git directory. You can only do one Git instance per directory or per root. You have multiple ones inside there, but it kind of gets confusing. I wouldn't recommend it. That only happens for really big projects, but it's just one Git instance for one project. And then if you are working remotely, which you can use Git without using a repository system like GitHub, Bitbucket, or GitLab. So you could just do it locally and make all your commits, updates, and changes there and use Git to manage it locally. But it's recommended to do remote so you have a backup, even if you're not working with a team of people. So this is how you would tie a remote to your actual application. So your GitHub service to the work that I'm doing on my local machine or to Bitbucket and multiple ones. Projects can actually have multiple remotes if you want to. So say a client was using GitLab as their main Git service, but then we also wanted an instance of it on GitHub, we could actually do that. So you can have multiple remotes for a project.
Does that work with like one push? Can you just say like Git push and it does it?
No.
Oh,
You have to do 2 different pushes.
Yeah.
Git ignore
was like different branches, or does it like mimic the branching structure?
No. So by default, your remote is origin, but you can add multiple remotes. So if I'm pushing, in the case that I have multiple remotes, when Eric goes through the code example, we'll kind of talk about that. But instead of saying origin, you would just say whatever you defined it. So when you add a remote, you have to give it a name in that case. By default, it's origin.
Yeah. And you'll have to sync your branches to your remote.
Yeah. And the reason why you don't want that manually happening is because you may want to push to like a client Git hosting service and not push to your your company's one and not push to the clients. So I use a lot of build services that use Git, and I only push those when I've reached the end of a sprint or a sprint review and I'm pushing to that to that remote. So git ignore is also something that you would really set up only once. So all these things so far, the initialize, the adding the remote, and really the git ignore happen in the beginning of the project. The first 2 really just in the beginning of the project. So if they sound confusing, and it's the first time you're doing it, and hopefully there's someone on your team that is more familiar with it, but it's pretty easy, and we'll talk about doing that in our demo. But a git ignore is where it allows you to say, I don't want to track these files. So an example of this would be if I had passwords on my machine that were for the project that I was working on, or some kind of environmental configuration that was specific to my local machine, and I don't want to be sharing that out with the team. So I can add a line, and it can be regular expressions that say, don't push this, don't track this to the remote branch. Don't share this with my team. It's also used a lot for compiled languages. So if you have a development branch or kind of like a source branch, and then you build to compiled or production or whatever that may be, you probably don't want to be pushing that out because that's going to vary based off of different environmental factors. Plus, it makes no sense because someone could pull it down and actually build it. So this is just a good way to keep your code base clean and also kind of protect yourself from sharing files that you don't need to be sharing. And we'll show you one of those in our demo. Add is one of the most important pieces. So where it's different than a lot of other, I can't think what they're called.
Version control.
Yeah, version control, thank you.
Yep.
I can select individual files that I want to actually track and then write a message to them. So I don't have to select all of them. I can individually handpick the ones that I want to, and they can either be new files or modified files. So it doesn't automatically, if it recognizes a file, it's not going to automatically push those out. And how you push them out is you add the files, again, they can be new or they can be modified, and I do a commit. And a commit is just a message, but again, it's that idea of a snapshot. So I could say I updated 3 files, right? And 2 out of the 3 were related. So 2 out of the 3, I want to commit together and write a message about what those 2 files were changed. And then from there, I would want to do a pull to make sure that there have been no other updates from the code base, and no one else has made any updates to those 3 files that I've updated, or those 2 files. And then from there, I would push. So take those files and then share them remotely with my team. So the idea here is you update, you do some development, you code, and then you add those files, you commit them and write what you changed, and then you're going to make sure that no one else has changed anything from the remote server, and then you're going to push them out. You don't always have to push after every single commit you do, because you may want to group them, especially if you're doing some experimental stuff. So an existing project. So this one, again, I'll call out, we have that add, commit, pull, and push here. So that's going to be very common. In every single one of these patterns, it's always adding files, committing, adding that message, pulling to make sure that I'm updated, and then pushing them out to share with everyone.
So do you have to do both add and commit, or just one?
You want to add, so you select the file. So it's the selection of the files that you want to then commit.
Okay.
So you kind of cherry pick them, which is a bad word, but you cherry pick the ones that you want.
Yeah, you want to stage the ones that you're going to be committing. Is what when we talk about those 3 states, when you add a file, you're staging that file for a commit.
And are there any merging tools if there are conflicts?
We'll talk about that.
Yeah.
So if it's an existing project, instead of doing the initializing and adding that remote, all I need to do is go to like my GitHub, my Bitbucket, or have someone send me the Git URL. And then from there, I would clone it. And then here, this is kind of like the process. So I clone it and then do this number 2. And then I get to my coding. And then it goes back to the same process. So what a clone is just bringing that remote, all that code, and making it local. So I go to like my workspace and I say, bring these files down here. And now I have them locally on my machine so I can start working with them. After you have the code on your machine, the best practice is to branch. And to make a true analogy and where the name actually comes from is think of it like a tree. So I have a tree trunk and then I have all these different branches. So they're all kind of deviated from the trunk and kind of derived from it, and they may be a little bit different. And as you go out more and more, they may have more changes. So branches are, you're taking your code and you're kind of making that snapshot and creating a new snapshot of it where you can start making updates, but you're not affecting the code remotely because I haven't pushed, but I'm not affecting the code that's from the initial branch that I branched off of. Again, this will make a little bit more sense. These definitions are a little bit hard because you have to define them with what they are, and they're named really well. I think that's what Eric said. I was like, man, it's so hard to describe them. He's like, they're just named well.
Yeah.
So a checkout is, in the code, when you're doing the development in terminal, these are kind of the same thing, but checking out would be switching branches. So basic project setup, again, that checkout or switching branches, I do some development, I code, I say I want to add these certain files, or I want to add all these files, and then I want to write a message about what I actually changed. So I did some development, what did I actually do? I want to make a message and make that snapshot. And now I've decided I want to share this with my team. So I'm going to pool to make sure that there weren't any updates that anyone else made to that code base. And then I'm going to push out and share it with my team. This is the basic flow. It seems like a lot of steps, but these happen like in a matter of moments once you get this down. It's always add, commit, pull, push. Then with an existing project, after I've already done my development, have gone through that process and say I'm on a branch. Now the next step is I want to bring that code into the other branch. So then I check out a branch, and then I say I want to make sure that branch is now up to date. So I'm on my local machine, and I want to make sure that branch is up to date. I then take the code that I developed on my other branch and merge it in, and then I can start coding, or I can do a pull push if it's changed to share it with everyone else. So what a merge is just combining two branches together. That's as simple as it is. And this is like part of the magic of Git. You know, everyone always says Git is magic. It's with the merges as well as the pools. It does a lot of things for you.
Yep. And then to emphasize again, all of these features of Git kind of help enable this collaboration, right? So when we work on a project with a team, we have all sorts of things that we use in our day-to-day tasks, right? We have email, we have texting, Link, Skype. All those forms of communication help enable a process here. And where Kevin just described kind of like the micro tasks that you deal with when working in Git, I'm going to talk more about the process as a whole working as a team. And this is called Git flow. And the key thing about Git flow is that it's kind of it's like the project process for creating good code, right? So here's a definition here. You can read it. No, go on. I'll talk about the main pieces of Git flow that we'll focus on. It's built of 4 main components. We have our master branch, our development branch, a feature branch, and our release branch. And so our master branch is kind of straightforward. It's kind of like the final truth for the code in our project. It's usually the code that's on production somewhere on a live site for our client. It's the code that's working somewhere for real stuff. And then we have our development branch, which is kind of self-explanatory a little bit, but basically it's where when we work on our own separate pieces of code, we bring things together and make sure it works. We do stuff like testing. It's usually set up on like a staging site or integration site. And then we have our feature branches, which is kind of this process that Kevin outlined earlier, where you'll pull down a code repository, and then you'll check out a new branch, create a new branch, we'll call it a feature, and then work on the code that you want to push. When you're done with that, you'll merge that back into your development branch. After the development branch has maybe a few other features, or maybe just your own feature, and it's been vetted and it works and nothing's broken, that'll go into the master branch. And then finally, we have our release branches, which may or may not apply on every project. But if you're supporting a large project, this may very much be the case. And essentially, these will kind of fall in line with your master branch, except if you do any sort of like super major changes that go to your master, you want to set them up in their own release. So that way later, if you have multiple projects working off different versions of your master branch, like legacy code working off of a legacy framework that you've since improved in your master branch, you can always push security fixes and things like that directly onto those release branches and not having them affect your future development on your master branch.
And I know a lot of people also bring up when it comes to branches, like you can branch as many times as possible. And there may be some branches that you want to clean up if you push them to the remote. So you can always do that at a later time if it's been merged into your main repository in one of those main branches. So branching is not something you should be afraid of. It's something that's actually really good in the process.
Yep. And so now we'll start doing some live demo.